Hey there, math rock stars. Let's look at some more examples of simplifying square roots. I made a list of the criteria that need to be met in order for an expression, a radical expression, to be completely simplified. And you may want to pause this video and write those down, or at the end of the video come back and jot them down on an index card or a sticky note or something, just so you have them to look at and refer back to. The first one is that no radicals can be in the denominator. And you can see kind of in our example over here that I have a 45, square root of 45 in the denominator right now, so that's a problem. I have to do something with that. I also, number 2 says I can't have any pairs of factors or perfect squares in the radicand or underneath the square root sign. So that's also a problem in the denominator, because I could take the square root of 45 and split it up, right? I could say, hey, the square root of 45 is the square root of 9 times the square root of 5. And here I've got a perfect square, right? It could be a pair of 3's, that square root of 9. I could take the square root of 9 and get just a 3. So I am able to pull a pair of factors or find a perfect square out of 45. So criteria 2 hasn't been met. The coefficients are simplified fractions or whole numbers. So right now, if I'm looking at the coefficients, that would be the -9 and the 2. And it's an improper fraction, -9 over 2. But it has been simplified as much as I can. I can leave it as -9 over 2. Right? I could write that as a mixed number, but an improper fraction is okay. In fact, I'm going to write that down here. Improper reduced fractions are okay. So there's criteria number 3, and criteria number 3 is all taken care of. I don't have to worry about that at the moment. And I'll check out criteria number 4. No fractions can be under a square root sign or in the radicand. Well, right now, all I have is a 45 in a radicand. Criteria 4 would look something like this, say 9 over 5, 9/5 underneath the square root sign. That would be something I'd have to do some manipulation of to meet criteria number 4. All right, so let's deal with the example here, -9 divided by 2 times the square root of 45. And I could either address the radicals in the denominator, or I could address the no pairs of factors that are perfect squares first. And I think I'm going to deal with number 2 first. And the reason for doing number 2 first is that when you break down a radical, you end up with smaller numbers, right? If I start with number 1, I'll end up with a square root of 45 in the numerator, and in the denominator, it'll just be, the numbers are just large. So I'm going to try breaking down the 45 first of all. So I'm going to split up the square root of 45 into the square root of 9 times the square root of 5. When I do that, the square root of 9 is just 3, and I can rewrite this whole expression now as the -9 over 2 times 3 times the square root of 5. So I've taken the square root of 45 and I've broken it down into 3 times the square root of 5. And if you have a question about how I'm doing that, just send me a text or an email and let me know. I'll either sit with you in class and help you figure that out, or I'll make another set of videos. But in any case, we'll assume that you know what I just did. And I'm good with number 2. So I'm going to just put a little check mark right here. I dealt with number 2. I don't have any pairs of factors or perfect squares underneath square root signs anymore. I cannot break apart that 5. I am good to go. All right, now what? No radicals in the denominator. Yeah, that's going to be probably the next one I'm going to deal with, this one right here. Let me just rewrite the problem. -9 over 6, right? The 2 times 3 is 6, times the square root of 5. So I want to deal with the radical in the denominator, and I do that by rationalizing. So I'm going to multiply top and bottom by the square root of 5. And when I do that, I have negative 9 times the square root of 5 in the numerator. And in the denominator, I have 6 times plain old 5. Square root of 5 times itself cancels out the square root sign, and I end up with just plain old 5. And now my problem looks like this. Negative 9 times the square root of 5 over 30. So I don't have any more radicals in the denominator, right? I can check that off. I still don't have any pairs of factors, perfect squares under the radicand, right? I can't break down that 5 into anything else. Let's just double check I haven't created another issue, however, with my other two criteria. So I'm looking at number 3 now. Do I have any coefficients that need to be simplified? So the coefficients are the numbers outside the square root sign, so the negative 9 and 30. Can I think of any number that divides evenly into negative 9 and into 30? Well, yeah, 3 will go into both of those. So let's see, if I divide out 3 from the top and the bottom, I will end up with negative 3 times the square root of 5 over 10. So 9 divided by 3 is 3, 30 divided by 3 is 10, and then I still have that negative. So I think I'm good now. My coefficients have been simplified. Let me just double check that I don't have any fractions underneath the square root sign. Nope, just the 5. And that one's good to go. So my final answer is this. Negative 3 times the square root of 5 divided by 10. Before I wrap up this video, let just me make a note that I can't do this, right? I can't say, oh, cancel out the 5 and the 10. Can't do this. That's not a good thing to do, because the 10 and the 5 are in different places, right? The 5 is underneath the square root sign. It's the square root of 5. And the 10 is a coefficient. It's outside the square root sign. And the square root of 5 is a very different number than plain old 5. So I can't just cancel out a 5 from each of them. So I'm done. I'll make another couple of videos just going through the process of those steps to be simplified. You should try some on your own.